Alright, chapter 1.4 is on complex numbers. Objectives, we're going to add and subtract complex numbers, multiply complex numbers, divide complex numbers, and perform operations with square roots of negative numbers. So the imaginary unit I is defined as I equals the square root of -1, where I squared is equal to -1. This definition we'll just have to memorize. So again, I is equal to the square root of -1, and I squared is equal to -1. The set of all numbers in the form a plus bi, with real numbers a and b, so real numbers are the numbers we're used to, and I, the imaginary unit, is called the set of complex numbers. So basically, one second. This is what we learned in 102, if you took it. A represents the real part, and the B, I, represents the imaginary part. So you have a real part and an imaginary part. When you combine them together, you make a complex number. The standard form of a complex number is written as A plus BI. You must separate the parts. Alright, so the form of a complex number, a plus bi, is like the binomial a plus bx. So you can think of I as a variable, and the b in front of it will be his coefficient, and a will be a constant term. To add, subtract, and multiply complex numbers, we use the same methods that we use for binomial. So let's look at a few of those. I am in your textbook on page 142. I'm going to start by looking at numbers 3 and 7. So, the instructions say add or subtract as indicated and write the result in standard form. Okay, so this is our problem, and it says we need to add or subtract as indicated. So the minus in front of this parentheses means you need to distribute the -1. Let's recall that. So let's distribute the -1, and we end up with 3 plus 2i minus 5 plus 7i. Then it's just combine like terms. As I said before, you can think of a complex number the same way you thought of binomials. You just need to combine like terms. So I have 3 right here and a minus 5 right there. So that's really going to be -2. And then I have 2i plus 7i is 9i. So your final answer is -2 plus 9i. Alright, let's look at number 7 now. Number 7 says 8i minus 14, quantity 14 minus 9i. Well, again, we need to distribute the -1 out front. So let's go ahead and do that. So we have 8i minus 14 plus 9i. Now let's combine like terms. And remember that you must have the real part first. So the real part is the -14. He is the only one of his kind. So I have -14. And then I have 8i plus 9i makes it 17i. So it's -14 plus 17i. Let me box up my answers. And let's keep going. Now let's look at numbers 9 and number 19. So the instructions said, find each product and write the result in standard form. Find each product and write the result in standard form. So -3i times quantity 7i minus 5. Well, just like before, we have this number out front, negative 3i, and we're going to distribute it in by multiplying. So negative 3i times 7i is negative 21i squared. And negative 3i times negative 5 is plus 15i. Now recall that I squared is the same as saying negative 1. So that's not really there. Instead, I have a negative 1. And I put it in parentheses because it's multiplying the 21. So negative 21 times negative 1 becomes 21 plus 15i. All right, let's look at number 19. So we have 2 plus 3i, whole thing squared. Well, this square up here tells us to take this 2 plus 3i and multiply it by itself. So 2 plus 3i times 2 plus 3i. And then we can multiply it out by using FOIL, which is just saying each term in the first group is going to multiply each term in the second group. So 2 times 2 is 4, 2 times 3i is 6i, 3i times 2 is 6i, and 3i times 3i is 9i squared. Combine your like terms, so I still have 4 plus 12i plus, remember I squared is the same as saying negative 1, and it's multiplying. So 9 times negative 1 is negative 9. And again, I still can put some like terms together, so the final answer is negative 5 plus 12i. Great. All right, let's keep going. What else do we have to look at? All right, so the conjugate of a complex number. For the conjugate of for the complex number a plus bi, we defined its conjugate as a minus bi. So all you really do is switch the sign. So the conjugate of a plus bi is a minus bi, and the conjugate of a minus bi, well, that is just a plus bi. You keep the real and the imaginary parts the same, and you just switch the sign. So if you were subtracting, its conjugate should be adding. If you were adding, then its conjugate should be subtracting. The goal of complex number division, the adding, subtracting, and multiplying all stayed the same as regular binomial, adding, subtracting, and multiplying. However, with division, that's where we see differences. So the goal of complex number division is to obtain a real number and the denominator. A real number means no imaginary part, so basically no I in the denominator. We multiply the numerator and the denominator of a complex number by the conjugate of the denominator. So basically, the first thing you need to do when you're doing complex number division is find the conjugate of the denominator. Find the conjugate of the denominator, and then multiply the numerator and denominator by the conjugate. And of course, step 3 would be to simplify. Okay, so find the conjugate of the denominator, multiply the numerator and the denominator by the conjugate, and then we simplify. Alright, so let's go back in our books on page 142. Let's start by looking at number 21. And it says, divide and express the result in standard form. So 2 divided by 3 minus I. That is our problem. If you notice, in your denominator, who are we looking at? We have an I down there. And we cannot have an I in your denominator. So basically, no I in the denominator. So how do you get rid of the I? Is by multiplying the top and the bottom, so your numerator and your denominator, by the conjugate. So the conjugate of 3 minus I would become 3 plus I. So you multiply top and bottom by 3 plus I. And of course, this is just going to be distributing and foiling like before. So I have 2 times 3 is 6. 2 times I is 2I. Divide by, well, let me write this way for a second so we can all see it. 3 minus I times 3 plus I. And now I'm going to FOIL this out. So I have 6 plus 2I. Divide by 9 plus 3I minus 3I minus I squared. So remember, take your time when you're doing this. You can pause the video and make sure you get the same thing I get. 9 plus 3I minus 3I minus I squared. And then we get to simplify. With the top, I'm going to leave alone. So I have 6 plus 2I. And then on the bottom, well, these cancel out because they're the same numbers but opposite signs. 9 stays 9, but I squared becomes negative 1. So it's like saying 9 minus, technically, let me say it this way. The negative and the negative 1 need to multiply together, so it becomes 9 plus 1. And we end up with 6 plus 2I divided by 10. And then remember, you must separate the parts, right? So really this is 3/5 plus 1/5 I. Let's keep going. Let's look at number 25. Eight I divided by 4 minus 3I. Again, I have an I in the denominator, so we need to multiply the top and the bottom by the conjugate of the denominator. So that becomes 4 plus 3I times 4 plus 3I. And just like before, let's go ahead and multiply it out. So 8I times 4 is 32I. 8I times 3I is plus 24I squared. Divide by, and let's multiply out the bottom. I'm going to multiply it out, verify that you get what I get. So I have 16 plus 9. Okay, so now let's clean this up. Let me verify that. 16 plus 9. So again, let's clean this up. I squared is negative 1. So this becomes negative 24 plus 32I divided by 25. And again, you must separate your real and your imaginary part. So it's negative 24 divided by 25 plus 32 divided by 25I. Alright, so now the principal square root of a negative number. For any positive real number b, the principal square root of the negative number negative b is defined as I times the square root of b. So what they're saying is if you have a negative inside your square root, the negative disappears and an I on the outside appears. Okay, so if you have a negative inside your square root, the negative disappears and the I appears on the outside of the square root. Let's again go to page 142. We're going to practice a few more problems and that will conclude section 1.4. So let's look at number 29. So 29. It says perform the indicated operation and write the result in standard form. Square root of negative 64 minus the square root of negative 25. Well, the first thing you need to do is simplify the I. Simplify the I, which means these negatives need to be taken care of, right? Take care of the negatives first. So the negative inside the square root disappears and the I appears on the outside. So this is I square roots of 64 minus I square roots of 25. And then you say, well, the square root of 64 is just 8, so I have 8I minus the square root of 25 is just 5i, and that equals 3i. Okay, now let's look at number 35. Negative 3 minus the square root of negative 7 whole thing squared. Again, the first thing you need to take care of is the negative inside the square root. So we're going to rewrite this as negative 3 minus I square roots of 7 whole thing squared. And then we need to simplify. Well, the square tells us to multiply this thing by himself again. So we have negative 3 minus I square roots of 7 times negative 3 minus I square roots of 7. And we multiply it out. So again, use FOIL. Negative 3 times negative 3 is 9. Negative 3 times negative I square roots of 7 is just plus 3I square roots of 7. Negative I square roots of 7 times negative 3, again, is plus 3I square roots of 7. And negative I square roots of 7 times negative I square roots of 7 is plus I squared, the square root of 49. Remember, when you're multiplying radicals, like let's take for example negative I square root of 7 times negative 3. Well, the square root of 7, the 7 is inside the square root. So he's not going to be multiplied by the negative 3. The negative 3 is multiplying the I since he's on the outside as well. Now let's look at negative I square roots of 7 times negative I square roots of 7. Notice that you have a 7 here on the inside of the square root and a 7 here on the inside of the square root. You multiply them together and they stay inside the square root. But the I's were on the outside, so you multiply those together and they stay on the outside. Now let's combine like terms and simplify even further. So 9 plus 6I square roots of 7. When you're adding your radicals, you leave the radical the same if they're exactly the same, and you add their coefficients together. So 3I plus 3I is 6I. And remember, I is the same as x. He's a variable. I squared is negative 1, and the square root of 49 is 7. And these two are multiplying together. So it becomes minus 7. So now you have 2 plus 6I square roots of 7. And then one more problem for us to complete. Let's look at number 43. Three square roots of negative 5 times negative 4 square roots of negative 12. Okay, so the first thing we need to do, like always, is take care of the negative inside the square root. So this becomes 3i square roots of 5 times negative 4i square roots of 12. Okay, that's good. You want to keep it blue? Yeah, I do. Now let us continue by simplifying, right? So when you're multiplying radicals together, go ahead and multiply them together before you try simplifying them and find the perfect square inside them. So this is going to become negative 12i squared, because that's it's 3i times negative 4i, and then the square root, 5 times 12 is 60. Good. And then, of course, let's go ahead and simplify, because 60 can be broken down. And since it's a square root, we're looking for a perfect square. So 60 can be obtained by doing 4 times 15. Is that correct? Yes. 4 is the perfect square. 15 does not have a perfect square inside of it. So then we can break this down even further to be negative 12. I squared is negative 1. So that's negative 1 times the negative 12. The square root of 4 times 15. So now we have 12 times, well, the square root of 4 is just 2, so we get a 2 on the outside. The 15 cannot be broken down, so he stays on the inside. So this becomes 24 square roots of 15. Alright, this concludes the video for chapter 1.4. If you have any questions, please email me through D2L, the email in D2L, the link above, or you can send an email to my Gmail. It goes directly to my cell phone. The Gmail is alexisxhurst@gmail.com. Do not forget the X. If you are working on your My Math Lab homework and you have questions, again, feel free to email me.